Hi everyone. All right, it's time to start studying for your test next week. So, these are the basics of science. We're going to go over some key vocabulary words first, and then we're going to jump into the scientific method. So, let's start with this first word here. We have observation. Observation, you're using your senses. Now remember, your senses are sight, sound, touch, smell, and honestly I should add one more here, right? I should add taste. We can taste stuff as well, but we don't normally taste things in class. So there's two kinds of observations. We have qualitative and we have quantitative. So a qualitative observation is going to be a description of the properties that something has. Usually you're describing or you're telling me about its color, its shape, what it feels like, what it smells like, if it feels warm, if it feels cold. If we're wanting to talk about how many there are, that's going to be a quantitative observation. Quantitative observation describes how much. It describes the length, the volume, the mass, the weight. Anything describing a number is going to be a quantitative observation. Best thing to remember here is that n. If you see the n here, if you see that n, that's your clue in, oh, I need to describe a number. All right. So after observation, the next thing that we studied was communication. Now in science, we always need to be communicating with other people, and we need to make sure that we're communicating clearly. So when I say clear communication, what we're doing is we're using descriptive words to give and receive important information. Now, when we're being descriptive, we're being very direct. We're not just saying, go get that. What we're saying is, oh, can you please get me that silver pen with the blue tip that's laying on the table in front of you? When we're using clear communication, we're being very direct, we're being very descriptive. There's lots of different tools for communicating, right? Talking is just one of those tools. We could also use numbers to communicate. We can use drawings, we can use charts, we can use maps, symbols, we can even use body language. All those are different ways of communicating. Now, another important thing that we have in science that maybe some of us take for granted is measuring. Measuring is very important. It allows scientists to record what happens. It allows scientists to recreate what other scientists have done. If we didn't measure, we wouldn't be able to recreate these great experiments that we do in class, right? And when we do measure, we're using the metric system. The metric system is a decimal measuring system. And we're using units like meters, liters, and grams when we're measuring with the metric system. Remember your conversions, please. In 1 kilometer, there's 1,000 meters. Conversely, there's 100 centimeters in a meter. Remember how to go between these, right? This is a chart just to kind of help you out. A lot of you already know this, but I want to make you aware that I will be asking you questions about unit conversions here. Now, after these 3 vocabulary words, we covered a word that was new to a lot of you. And that was an inference. An inference is a guess based off your observations about something that's happening right now, something that's happening in front of you. Now, this can be a scientific opinion. An inference is all about what you think. An inference is not just a random guess. An inference is based off what you see. So, for example, when we looked at this picture of a cat, a lot of you guys observed, oh, there is a orange cat under a table, and that cat is next to a broken flower vase. Those are observations. Now, an inference for this picture could be, oh, that cat broke the vase. That would be an inference. It would be a guess about something that's happening right now. I'm guessing the cat broke the vase based off my observation that the cat is standing right next to it. Now, inferences about right now, but we can make guesses about the future too, and when we make guesses about the future, that's called a prediction. A prediction is a guess or a forecast of what a future observation might be. Usually reliable predictions are based on careful observation, notes, and inferences. Now that we've covered the basic vocabulary words, we can get into some more specific words. Variables. Some of you guys had trouble with this. Variables are items that we can change or measure in an experiment. So when we're testing, we could change things, we could measure things, and those things that we change or measure are what we call variables. Now there's three specific kinds. We have independent, dependent, and controlled. They all do slightly different things, but they're all variables. Now our independent variable is the variable that we can change. Think about the I in independent. I change. Independent. I change the independent variable. That is what you change. Dependent variables are variables that change because of the independent variable. They're dependent on what the independent variable is doing. Normally, the easiest way to remember the dependent variable is what you measure. Whatever you're measuring, that is your dependent variable. You could be measuring time of something. You could be measuring the length of something. You could be measuring the width of something. Whatever you're measuring, that is your dependent variable. Now, the easiest one to remember is right here, the control variable. This is a variable that does not change in the experiment. It is what you keep the same. So, for example, in this picture, the sun stays the same in every experiment. So the sun is a controlled variable, the weather. The flower pot stays the same in each experiment. So the flower pot would be our controlled variable. Something that we change in this experiment is the amount of water. We have no water. We have 20 milliliters of water, and then we have 40 milliliters of water. Since water is what we're changing, the water would be independent. Dependent would be if we were measuring how tall the flowers were growing or how big they were growing. Anything we measure is dependent. All right, now that we've got basic vocab out of the way, let's talk about the scientific method. Now, the scientific method has basically 5 steps. First step, observe a problem. We have to have a question, right? We need a question. Second step, form a hypothesis. You got to make a guess. Now, hypothesis is just a predicted explanation for an observed event or problem. Your hypothesis doesn't have to be right. It can be wrong, that's fine, as long as you base your guess, your hypothesis, on an observable event. So, step 1, observe a problem, have a question. Step 2, form a hypothesis. You need to have a guess about that question. Sometimes between step 1 and step 2, there's a mini step where you do a little bit of research. But for right now, let's focus on these 2 steps, okay? Step 1, we have a problem. Step 2, we make a guess about that problem. Step 3, we need to test our guess. We need to see if we're correct. Now, when we're testing, we need to be sure to write down a clear procedure or a clear series of steps so we know how we tested and we can show to other scientists how we tested our guess. After experiment, we have step 4. Step 4, analyze your results. Do your test results tell you if your hypothesis is right? Do your test results tell you your hypothesis is wrong? This is the step you're going to find out. After your test, you need to see if your results match or do not match your hypothesis. Step 5, communicate your conclusion. Explain why your results don't match. Explain why your results do match. This is a great place to talk about what went wrong in the experiment, a great place to talk about what went right, why don't your numbers match, why do they match. This is where you're communicating your conclusion, you're communicating your results. Those are our 5 steps. Now, after step 5, sometimes you just start right back at step 2, you take another guess, and then you go on back to step 5, and then you can go back to step 2. The scientific method can be kind of a cycle, right? If you find out your hypothesis is wrong at the end, then you can start over, make a new hypothesis, and test again. So the scientific method, while being a list, can be seen as cyclical, as a circle, because you can continue to do it for the same question. All right, guys, remember, a lot of your notes are going to be on haiku. Looking at haiku here, in order to find things, you guys are always going to start on the home page. You're going to press units. And then here you guys are under standards of science. You guys are going to find your notes. All right, you guys, good luck, and I'll see you on Tuesday.